listening to me.
What if we are?
You're gonna have to suck it up.
Shut
So a lot of times, so for the past, well, it must be a year and a half now, at Red Hat I've been doing AI stuff internally. Now everyone else is doing it. Yeah? The reason why I'm doing it, well, at Red Hat we have a lot of security data, a lot of security tooling, and it would be good to use LLM to help automate some of our stuff. And throughout this sort of year and a half, how many people here have implemented an expert system in Prolog or using horn clauses? Yeah. So because I'm a really old guy, I did that once, and I've done a few other expert systems. And once again, when new humans are made, they make the same mistakes like over and over and over again. They think that what we're dealing with is something new. And I thought it might be nice to do a little presentation with curl. But this is a discussion. Ask questions. I'm certainly not the expert at it, but maybe I can remove some of the myths here. Oh, I don't want to share that. One moment. Okay. Right. So when we talk about AI, it's a big circus tent. Yeah, it's not just machine learning, which is the sort of thing that's walking down the model, the fashionable model down the runway today is machine learning. And if you go through AI, there's a whole bunch of things in here. Yeah. I actually implemented a graph data store. So I'm sort of what you would call a logician. Yeah, I like the idea of having data primitives in a query language and things you can understand and talk about. Whereas machine learning people, they think it's bad form to touch the data. Just throw it all in as it is, and you'll get the answer. Yeah. And I'm like, oh gosh, because there's always the garbage in, garbage out principle working with all of data. Of course, the logicians are wrong as well, because they think they have enough time to mark up everything beautifully, and there is never enough time. Yeah. So both polar opposites of all AI is incorrect. So there's this sort of bubble of AI. And people think, oh right, if I know deep learning, then if I know machine learning, then I know about neural networks, and then I know about, no, it's not like that. People who do semantics don't talk to the people doing machine learning, don't talk to the people doing sort of low church AI with support vector machines and neural networks. You'd think they all talk to each other, but they're all learning individually and building their own stacks of software. So once again, it's turtles all the way down. So when the ancients saw this turtle coming out of the ground, they're like, God, the continents are based on turtles. But in AI, it's parrots all the way down. We're talking about simulated intelligence. There's nothing, especially with machine learning. We're talking about the prediction of text tokens on the level of your phone doing auto prediction. Yeah, there's nothing else going on. People can say whatever they want, but all it's doing is saying the probability of the next text token. So basically, when we're talking about machine learning, we're talking about a new world of text token-based computing, which is insane. Yeah, because it's too much indeterminism, too much. We're going to spend a lot of energy and time trying to fix all the problems of basing on an architecture of text token computing. The heat death of the universe will happen before we come up with a logical system. But of course, we're going through this typical, it's great, and I'm hopefully running up the slope of enlightenment, but a lot of people are still going to the peak of inflated expectations. What does it mean? At the moment, probably at all your companies, everyone's saying, use AI, yeah? And they finally got their GPUs or some account that you can log on to and start tip-tapping away and getting answers. But there's all sorts of things that matter and things that don't matter. And with hindsight, everything's perfect. When the first wave of AI happened, we had Tercom, and Tercom is terrain mapping. And so it blew people's minds away. Well, before, when you put a missile anywhere, you had to have a wire connected to it because it didn't know where it could go. Yeah, and it didn't have enough smarts to say where to go. and we certainly didn't have GPS. So to put a missile anywhere was very bad. But someone wrote TERCOM, this expert system in Lisp that did terrain mapping. That meant that the missile could leave home base and figure out, based on a very small sort of compressed set of parameters, and actually arrive somewhere. The reason why I know about this is because I did geophysics and I did gravity mapping, and apparently all these TERCOM systems needed gravity maps too, because you can't put a missile, especially a ballistic missile, anywhere without knowing the gravity deltas from you to there. Otherwise the missile will be hundreds of miles off base. Yeah. And I actually met one of the people who did TERCOM lists. So like, he was like, Jim, and this is a long time ago. This is like I was probably mid '80s. Yeah. He's like, Jim, I've already been through a few of these revolutions of simulated intelligence, and now it's 2025. It's almost it's like a long time ago. Someone I feel the same way as this guy. Yeah. I'm not saying I'm right, but we always seem to be wrong in certain respects. So I worked on Deep Blue versus Kasparov. I actually didn't do anything with the computers. I worked on the network between the chess viewer and Deep Blue, and I got to sit next to the programmer chess masters. It was really cool. I like chess. I used to play a lot of chess. I don't anymore. I don't have time. I don't read anymore. My kids take all that time. But anyways, what I learned there was. What did I learn there? I said, when I sat down and I remember Kasparov losing, the engineer, one engineer was like, you know what, we have a real big problem, Jim. We're writing these programs, but we don't know how they're winning. And he's like, it doesn't matter if we write a super program that wins all the time. It matters if we write a program that tells us how we won. Yeah, because otherwise, you never know. So it's very important that any expert system you have has transparency to it, because it can be explained. This explainability that resonates with me deeply right now, because if in security, you say a CVE has a high priority, you got to say how and why, and all the contextual differences. It could be high in this certain context. It needs to be explainable. Otherwise, it's just sort of like weird machine lawyers talking to each other in a weird language, that no one understands. Yeah. NASA rovers using, millions of miles away automated systems. Obviously, we have email filters. We have all the stuff coming out. So in the beginning, and I'll get to the curl bit. Yeah, sorry. In the beginning, people want to do stuff like. Bear with me whilst I get to somewhere. Yeah, I'm going to run something, and there are lots of ways to run locally LLMs. Yeah, you can use VLLM, which I like. Olama, there's all sorts of things you can run. You need GPUs, et cetera, et cetera. I'm running Tiny Llama as one of many models, whatever, and I'll say, tell me all about curl. There's nothing magical about this. It'll spit out some text that it says, probabilistically, this is what you probably want. Yeah, it'll be somewhat correct. And what's important, I get to use the whiteboard now. Yeah, okay, can you see this? Okay. So what's important is when you talk about a model, LLM model, it's sort of like a compression format of the entire internet, yeah? It compresses down a lot of knowledge into a smaller representation. So you have a time horizon of what this knows about. So this only knows about what it's been trained on, yeah? At query time, what I just did right now, I asked the query, and it just, it has a constrained domain of knowledge. If I asked about curl, let's say we do a release today, and I asked it about curl, and I said, "What's its latest release?" It won't be aware of that knowledge. Yeah. So all these systems have a temporal constraint. So what happens when new people make systems? We can fix this problem. At query time, we're gonna inject new information. The first step was we'll just train models again and again and again every day, half a day, every 2 days. But models get so big that you can't do that, and you don't have hundreds of millions of dollars and lots of electricity to burn through to mint new models every day. So going from some compression process to some runtime analysis is very important, because when you're dealing with data that is based on text probabilities, you automatically have chosen a way, that choice has made it hard now to keep up to date. So this is where the logician is. It's aha, fools! You could have just chosen a system where you can incrementally add the data over time and not have to retrain the entire freaking model every time. Yeah, but we're in that world. So I could have never imagined that. You can imagine machine learning people and logicians knife fighting each other. They hate each other. It's like they think they're both heathens and primitives and to each other. But what I particularly enjoy is the irony that machine learning is now making knowledge graphs popular. I could have never thought in a million years that the reason why people would want graphs is because of machine learning gaps. I'm particularly happy about that. Anyways, back to the story. So, when you get, everyone talks about hallucinations, right? So if I go to curl and I say, I don't know, I'm gonna go to a different AI. There's all sorts of different AIs, and I'll ask about, and DuckDuckGo has AI chat. One of the nice things about it is it doesn't take any copy of your information, so you can just type away. So let's, who is the best? No, I won't do that. Who runs curl?
Who makes the most typos in the process?
Yeah. Let's. Okay. Well. Okay. What is the latest version of curl? I just can't see it. Okay. So that's going to talk away. And I've chosen a model, Llama 3.3.
Okay.
Latest version of curl 7881. Right. So I told you it's been trained, and it only knows what it knows. Yeah. And
2 years ago?
oh, interesting, isn't it? Yeah. So, but it can also lie too. Yeah. It might have that information, but it might think probabilistically this is what you meant. Yeah. Now, when people say hallucinations, I can't stand it. It makes me freak out because it's the wrong word. And people say it, bandy around, oh, the machine's hallucinating again. It's like, no, this is a very well-known concept. We don't call it hallucination. In my world, we call it open world assumption. And how many people have heard of open world assumption, OWA? Yeah. So if open world assumption is a very, very classic boundary in data in computers. There's closed world assumptions in design and open world assumptions. Yeah, and we know what this means. Like when you have a closed world assumption, I guess let's take a SQL database. It's a list of employees. And I'm in the Red Hat database, yeah, James Fuller, but Stepan is not. So our assumption is Stepan is definitely not a Red Hat employee. That's a closed world system. In an open world system, we can't make that truth, yeah. It's not everything is up for falseness, yeah. Just because there's a lack of data about Stepan being there or not is not an assertion of him being an employee or not.
Okay.
So open world assumption, you've got to build a lot of different systems, yeah? Because you cannot assert with truth based on the relationships at the atomic level. And because of that, because models don't have, because all AI systems have OWA, yeah, semantic web has it.
So there is just positive proof, but not negative proof.
Yeah. And it's really, but interesting things can happen because of an open world assumption. Like in graphs, I could say Daniel is a man, and we can assume, oh man, human must have had a mother and father. There's inference that can go on, right, based on that. Must have a mother or father? I mean, we could probably like biologically recreate Dan somehow. We hope for the 100 years of curl.
Yeah.
Or maybe your son doesn't know it, but he's going to be running your stuff. But like open world assumptions open up a whole world of new ways of thinking of data, and this is just what's happening now with LLM. People are like, oh, this is crazy. It's lying to me. It's not indeterminate. Well, yes, but if you know from the beginning your data system is indeterminate, then you build in ways of querying the data because of that. Any questions? Is this interesting? No? No? Okay. Right, so the way I look at it, because I worked on databases for like 10 or 15 years, is in LLM, there is no schema. It's dynamic. It's partial. There is no data primitives. There's no query language. And because of all that, you have an open system where at any point in time you have the superposition of unknown, partial answer, wrong answer, correct answer, right, wrong answer. Yeah? And people like to use LLMs like databases. Yeah? Their expectation from most programmers' point of view is assertion of truth, right? And they get surprised by this fact. And then they go, hallucinations. And it's just not that. It's the side effect of the design choice that you've chosen. Yeah. By the way, there is a mathematical thing called hallucinations that does happen, and there's a very well-known paper by it, but that only happens about 1% of the time. Yeah. And no one's referring to that. They're referring mostly to this. Yeah. And they don't know the difference. Sorry, I've got that off my chest now. So curl. So remember, we've got a limited time horizon on some models here, but we also have data. Yeah. So what went into this LLM about, let's say, a specific CVE of curl? Yeah. Well, we have different opinions. NVD says, well, let's just look at the one moment. Let's look at this 2024-6197. We say this is a severity medium, and we explain it all, and we do what we need to do. And then we got other people who have different opinions. So NVD, they're doing a reanalysis, excellent. NVD thinks this is a 7.5, yeah? Yeah. And Red Hat, I hope is more correct. Yeah, we got a 5.9, yeah. So what happens when you train the model on the internet and you ask a question about this CV? Confusion, lies, truth. Does it go for the average between 7.9 and 5.5? No. It sometimes chooses one, sometimes chooses the other. So if I went and asked, well, I haven't actually tested this out, but if I go and ask, which one should I use? I'll use chat. Give me a moment. AI, and go, what is the severity of, well, I have no idea what this is going to come up with. Oh, it doesn't even know about it. So it was trained before. Yeah, it doesn't even know. So I'm going to go to my other, I think I've already done it here, so I'll put a
correct answer.
What is the severity of, yeah. So Gemini is more real-time, runtime, blah, 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 blah. This is Google stuff. And it's actually quite interesting. It has more visibility. It's telling you how it's synthesizing the answer. And it goes with why is Google preferring NVD? Why? Because it is, yeah. So you have to know about LLMs. You have to know how the data here is tainted. At Red Hat, if we want to get correct scores, we have to train our own models. It
actually mentions the other ones a bit further down.
It does, and that's better than it used to, yeah. And there's actually strategies for getting two answers incomplete that is more coherent than combining, two answers into one that are both wrong. That is always wrong. Anyways, that's not the point. I wouldn't, what's happening now is someone's coming up with a new CV and going, what is the CVSS score? Yeah, guessing based on previous knowledge. And you have to know that all the answers are based on the data. So if your data is tainted, you need to be aware of the taint, how it's tainted. It's like dropping ink into water. It's hard you can't reverse that out. Once it's in the model, there's no corrective query time thing you can do to isolate the namespace of information here. It will always be a problem. Yeah. So if you don't know how the model's been trained, you really don't understand what's going to happen at query time. But people are trying to fix everything with band-aids at query time because it takes hundreds of millions of whatever to.
You're not hallucinating.
Yeah. Yeah. All right. So. Oh wait, sorry. Let me try. That was that. Right, so there's different levels of AI. Right now I'm showing you the top level, and that's where everyone's going because you're going to get the best answers. But actually, just using neural networks or support vector machines, you get a lot going that way. And I always tell people, before you pour all your data into or train a model, actually just do a simple neural network or a support vector machine, and that'll tell you more about your data. You pour all your data into a model, you don't get to understand the constraints of the data because that model will try to be as authoritative as possible with the data it's given. It's not going to tell you, like if I was going to use a support vector machine or a neural network, I can understand, let's say there's 60,000 CVEs. Out of those 60,000, there's probably going to be, 1,000 criticals versus 50,000 lows. That's pretty unbalanced, right? So any analysis of the data, you have a few buckets of severity, and one is really unbalanced. And usually in a probability class, you have to deal with unbalanced classes. Because why? Because if I train data on it, I have more examples of low than I do of criticals, right? So I'm always biasing the training of the lows. You don't know that when you pour it in here, yeah? The LLM doesn't know, I've got a lot more examples of low than critical. It just does what it tries to do. And by default, you have a biased model because of that. In lower church AI, you can see, it's really clear that when you use a neural network or a support vector machine, how it'll be wrong, be clearly wrong, and you'll know why it's wrong. Whereas here, it's almost to the point where, so anytime you do LLM stuff, precede it by some simple approach first, so you can understand the data you're training on. Right. So fine-tuning models. So once again, we've talked about the two details. Sorry, I went backwards here. Right. So novelty. So imagine today we get a new CVE from this from HackerOne. Like I said, there's a boundary of what the model knows. Now this is my test case for our internal CVE stuff. If it doesn't know about nuclear missile launch codes that can destroy life on Earth, in fact, it does a pretty good job. If I put this, I'll put this in and I'll ask Gemini to figure out what is the severity of a CVE with the following description. It should do pretty well. And this is one of the problems with any training method, low church or high church. If it's never seen it before, that's another dimensionality of doesn't know about it, right? It should come up with a pretty good answer because hi, pretty good. But this thing doesn't really know anything. Yeah, it doesn't have any inference or reasoning system. So like a knowledge graph has a little bit more of a chance to answering this problem more correctly than just text probability. So what's the point here? So I've sent you guys, at the bottom of curl-up page, there's a link for you two to look at. If you could do that now, that would be great. Just as whilst I'm talking. And you know what's happening. I think I've given you access as well. So what do people like me use AI for, right? So I think I like to use it as a scouting ahead for algorithms type stuff, right? I like to use it for optimization. In other words, if there's a bit of code I can optimize, or SQL or whatever, I can pop it in and get a quick answer. It reminds me a lot of generating code generation techniques, right? There's a lot of code generation techniques that just generates lots of code. And we've all been there before, code generators, and we commit that code into our repo, and then 5 months later we have to regenerate all the code, and we keep on doing that, and then eventually we're like, why am I doing this? Because I have to poke into this generated code, tweak some things. The whole AI thing doesn't work well in the sort of develop, compile, build loop. You have to break it up. Its extensibility has to break up so you don't rebuild the entire thing every time with AI. You know what I mean? So I use it for higher starting points. I use it for scouting algorithms, yeah, because my brain gets old and I can't remember everything, as an enhanced code search engine. But it doesn't matter if you don't understand what's going in here. I know the pitfalls because I kind of can already see what you have to do to this to make better answers from. So one way to do it is we can use I'll just go to garbage in, garbage out, 1 moment. Right, so one way to do it in LLMs is RAG. How many people have heard of RAG? Yeah, okay. So at runtime, we're gonna fix LLM basically. we're gonna inject information from a concrete data system that is making concrete assertions. And that will sort of adulterate the output and help inform the query into the LLM. And the idea is we'll get better answers, less hallucinations, more correct things. And the first step of this was to vectorize everything. Now you don't need a database to vectorize, to have a vector representation of data. But database vendors need to sell something, so they, please use our database with a vector representation. Yes, you can do it in code, just in pure code, and that's what I've done. I've written a little Rust program. One moment. One moment. I think this is it. Okay, so yeah, this Rust program, what it does is it vectorizes the curl source code, and it runs a model. I'm just using Tiny Llama. I could use some really advanced model, but I don't have any GPUs on this particular box. And I can ask it questions, right? So don't expect good answers, by the way. So I'm just going to ask, I don't know, anyone have a question about the curl code base? Where in source are cookies managed? Okay, we'll just.
Where are the cookie vulnerabilities?
Okay, yeah. Well, that's what people are doing. Yeah.
Undiscovered vulnerabilities.
Undiscovered.
Undiscovered, yeah.
The secret ones.
Yeah. So what that's doing is going to the model. It's going to the vector representation of the source code, and to the two shall meet, and that means better answers, right? Sure. Based on the code snippets for the curl, here's how cookies are managed in the local port flag. Rubbish. Yeah. So once again, LLM plus band-aids.
The cookies I sent to the TCP Peoplelite protocol.
Gobbledygook, yeah? So once again,
Junk.
so this band-aid needs a band-aid on top of it, right? And I didn't have time to write a graph rag, but it turns out that a lot of computing knowledge is represented by little trees. I mean, we all talk about ASTs and abstract syntax trees, right? It turns out that marrying a knowledge graph plus to be the RAG at runtime with an LLM, you come up with some pretty good things. So at the moment, I gave you guys that document. So I'm going to show you the document. Now, I don't think it's particularly good, but this document was generated by Gemini. And basically, I gave it a prompt of, tell me the security vulnerabilities of what you think of libcurl 8.13.0. And the output is very similar to a lot of output I see from people, in that it seems on the surface competent and comprehensive, right? But if you dig down into any detail, it can fall apart a bit. So what did you guys think, scanning it?
Big.
Yeah, wall of text. Yeah.
Lots of pages.
20 pages.
Yeah. You could probably see someone generating this. Now we're moving into a world of apparent
it's quickly recognizable that it sort of it repeats a lot of information that it found in the previous audits and so on. So it repeats a lot of valid sort of information.
Yeah, and this is where computers always make things worse. But is this going to be this kind of like apparent competence is going to become de rigueur at scale? Think of the AI reports we're getting. They're just drip drives, but I feel that in a very short period of time we're going to have thousands of those reports. It's going to, this is the potential for AI to break all sorts of business models because of scale. Yeah, and apparent competence is a real problem.
And the challenge is that, I mean, once you step up your timeline,
Yeah.
what's the next input data to train on?
Yeah.
If it's, I mean, it will partially be the output of the previous generation, right?
Well, this is the idea of using GraphRag because I can inject it at runtime dynamically. Yeah. So
Yeah, but
you stop
eventually-
training. You stop training all the time and train only when you must.
Yeah, but it's meaning sort of like it's going to eat itself.
Oh yeah,
So
it'll be so
half
big.
the world
yeah,
will then
yeah.
train on this that was generated based on
Right,
random,
right,
so
right,
it
right,
will sort
right,
of
right, yeah. And
incest.
so, the end result of this, in my mind, I'm that old guy in 1985 who, with weary eyes, asked a few questions. He's like, Jim, do you care if a car outruns you? You know, do you care if an excavator outdigs you? You know, do you care if if software beats you at chess? And then it flipped around. Do you care if someone takes your job? Yeah. Do you care if someone takes care of your kids? Yeah? Do you care if they take over your identity? Now, between the top and the bottom, I'm struggling with the current AI thing because I think the top is more like horses have replaced cars, and that's always going to happen. Those kind of optimizations, and we just retrain and redo things. And I think mostly this is what it is. And there's going to be a lot of jobs that apparently don't need to be done because we could just use a bit of software to do it, right? But then there's the second thing, and I'm not quite certain what it means. Like takes your job, yes, that could be part of the horses replaces car thing. But what if Stepan sends his LLM to work tomorrow? And he doesn't show up for a month, and he's writing a lot of code for him, and he's just doing reviews on it. And like, yeah, it's apparently well. And then you got fired, one day. And then, anyways, there's all sorts of things that a world I can't imagine that I really don't understand.
Taking the large picture is the business model of the AI companies now, and like we do not hire people unless someone can justify that you cannot use AI for the same blah blah blah. All this what you hear from the tech pros. This is for the society. It's totally self-destructive.
Yeah.
I mean, if you optimize your company to in that extent, and everyone optimizes their company in that extent, who is going to buy your product, or where does the money to buy your stuff come from then? If you have just optimized the expenses on your worker and wages. Mm-hmm. That's just a global picture where I do not see any concept of how this should be working on a global scale.
Yeah, I mean,
apart from everything else.
There's just, I can't really comment to that level. I try to bring it back to what does it mean to me as a programmer sitting there. A long time ago, I asked, maybe we'll become code farmers, because we don't really have the tools to directly manipulate all this stuff. So we choose models based on desired characteristics and mate them, and they have baby models, and we indirectly program now, yeah. But we can directly program DNA now, yeah. We could probably make a cow from beginning to end, programmatically. We can't do that with text token computing yet, yeah. Anyways, because I've been doing this a long time, I've always done the genetic algorithm. This is one of the things last year with the genetic I can't remember, but the genetic algorithm to me is my favorite approach. And I think all this is just a preamble to getting to GA chips at some point. So one of the things is that LLMs only have the endpoints. In other words, even like this is a famous video of Picasso making $1 million work of art, and he goes from drawing a cactus to a fish to a chicken to the last thing. Yeah. LLMs never have the starting point. Yeah. LLMs only have the end point of everything, and then they work out. But they can never be Picasso. Yeah. They can't. And I think Picasso would have a lot of fun with LLMs, in terms of messing seriously with their minds. I think we should, if we understand that it's only ever going from what it knows. There's a boundary implicit. It can never just spontaneously generate a novel thought. And that's not necessarily true. I mean, in a graph, if you have 2 points, we can discover inferred nodes, like I said about Daniel having a mother, because he's human. That we can, the search space can be searched. Right? Right. Hardware changes, GPUs, quantum chips. So my advice to you, as programmers, stay calm. In a few years' time, everything will be different, but the same. Yeah. Some people will lose their jobs. Mostly layer 8. Stuff can be used by AI, but what does it mean for curl? Like, I think it's already been shown by the AI stuff that surface level of analysis just isn't there yet. But I think maybe in 2 years' time, you might see code generation techniques with other systems, and it's something to think about. Because if you look at Rust, with Rust, I can generate code, and if it doesn't work, the compiler will tell me, you got to fix this, fix this, fix this. And that might be amenable to AI-generated code progression, yeah? Because the AI agent can just keep on generating code and then fixing the code, and then it gets something running. That might be more computable or more tractionable than C code. We might be able to augment C code to do that. But I don't, we're still some time away from generated code. But like if you look at DNA is messy. Maybe we're moving from a world of elegant code that's efficient to we're okay with mess. We're already okay with megabyte home pages. What if it's a terabyte home page? Doesn't matter. Yeah, if it's written by someone else, horribly and fast enough. Yeah, what does it matter?
I think in general, it doesn't matter when you're doing it on top. I mean, it's like, it doesn't matter if you mess up your plumbing in your house, that's fine, you can do that. I mean, everyone can do that in their own house, and that's fine, and you can generate whatever plumbing solution you want in your house, but you can't build a society on plumbing that way. And that's the same way it goes for software too. Sure, everyone can play around and be fools on top of everything, but that's not the way to build a foundation. We can't do everything that way. And I think that's forgotten a lot of times. Sure, people can do a lot of fun apps. Ask an AI to write it, and sure, it'll do it quickly and easily. And if you find a bug, just rewrite it again, and it'll work. But yeah, it's easy said when you're just fooling around.
Well, but the bed plumbing, that's like JavaScript for bed
Yeah,
plumbing.
yeah.
And right, we use the bed plumbing, and it kind of works.
Yeah, but I would still say that most of the JavaScript is still on top of everything. You still build it on top of a foundation that sort of needs to work.
But it's ephemeral. Like, that layer 7 is being rewritten over and over and over and
Yeah,
over,
yeah,
and
and
over
that's
and
fine.
over again.
And
And that's what I guess the point is. So I see these code generation techniques, which we have many different code generation techniques that have nothing to do with AI. I can see them being used up there. And in fact, you could kind of think of like ORMs and all these frameworks as code generators as well. Most applications are database applications, but we run a lot of code that auto-generates a lot of SQL. You know what I mean? What's the difference? But I see it higher up the stack where this is going to have an impact. Yeah. Anyways, or not. There are existential threats. It's not just about the horse replacing the car. Yeah. We've already seen sort of the top one. Yeah. And that with low church AI techniques. Yeah. The second one kind of XZ reminds me. It feels like people can be targeted, not one person, but imagine targeting an entire company with 20,000 people to influence something. Yeah, the scale is, we can operate at scale with these sort of tools we're making. I keep on saying at work that we got to think of the stuff we're making. Right now in Western China, what they're doing with AI is absolutely crazy. Yeah. The level of mind control that's going on, and even when you have willing, knowledgeable participants in Russia in terms of the firewall they're dealing with. The other thing is distributed exploits. In other words, when we're talking about CVEs, like with curl, it can be not just a 1-point thing. It could be 2,000 points. Who cares? The LLM doesn't give a toss if it's a 10 or 1 or a million. Yeah, it can be very obfuscated. These distributed exploits. And then I think I just added apparent competence because it kind of feels like a lot of decisions get made based on apparent competence. The LLMs have told us that this is going to happen, and it's like it just kind of feels that it's a denial of service on humanity in terms of you got to read all this stuff to deny it or not. We haven't even entered the world of advertising, LLM, yeah, or that's another world I don't want to live in, but yeah. Right, thank you. That's all I have to say. I'm so sorry it wasn't that much about curl, but I thought, if there's any questions you have about AI or how you think it might impact curl, or fire away. Cheers.
Wonder how you talked about the RAG, which you vectorize the code source code. How did you vectorize it?
I wrote code.
Is it like code function or
Yeah. I just wrote code to make a vector data thing. Yeah. So you can use a lot of Postgres has a PG vector, and you can pour data into that. You don't need a database. You don't actually a vector representation. You don't need ACID everything. You just need it in its final form. That could be a text file that you load into memory. Yeah, it doesn't need to be anything. But you don't really want to use vectors because they are a band-aid. They're just providing runtime data, so your time horizon is closer to now. Yeah, right. So you don't have to retrain the model. You want to use something with a bit more data weight to it, like a graph that has data primitives, has ability to query. And you also see model MCP. I noticed that Apify has MCP support. And this is a way of standard inputs, data inputs can be brought into like RAG for here. So at the moment that's where I see that, and if that document I showed you guys, that's the output of a graph RAG model with Gemini. That's the tippity top pro research level mind, and it's still kind of meh in terms of quality.